All right, we're back. We're on page 201 of Math Analysis, Notes 15. It's the final page of the parametric notes, and it's one really long problem. And I mean, it has a lot of parts. I gave this as a test one year. Uh, it didn't go great for a lot of people, but it went really well for some people. So, you know, pluses and minuses. But when I initially gave it, it's just like a sheet of paper. It didn't have the questions broken out, and then eventually I went back and broke down all the questions. So the key, we're gonna make this happen in Geogebra. We're gonna do that as we go though, because like first of all, it just helps you to know if you're getting it right and getting it wrong. Let's start reading through it. We got to pick out a piece of information. It's basically I imagined an amusement park game, kind of like a virtual game though, really. So an amusement park, we have a shooting gallery that's set up, so you can shoot like lasers at things, and targets can move back and forth, but they don't actually move back and forth. They just move from a point to another point. We're not going back and forth. That just adds a dimension we don't really want to deal with here. Each target moves at a constant rate along a specific line segment. Okay, so that seems fair. Targets go from one end to the other and do not return. So they don't return, so it's a one-way trip. Game is reset for each participant. People running the game can play around with how fast the different targets complete their trips. People playing the game must take their shots. So this is the first like mathy thing, I think. Well, all of it's really important, but people playing the game must take their shots from anywhere on the circumference of a circle. So circumference of a circle centered at the origin with a radius of 20. I don't know why I didn't highlight all that. Okay, so let's start there. So I actually, because I think this is going to be nuts, I'm going to be using another sheet of paper to like draw some stuff and try to work out like what's happening. So I think what's happening is we have this, and so I don't know. I probably should have started with the axes, but I didn't. And so now what? I discovered today actually, that there's like graph paper that I could be using. So I don't know if that's helpful. It's called stickies, and you can put a grid in, and then you can make the grid like bigger, like a lot bigger potentially. I can't resize. Oh, maybe I can resize it. Maybe the bigger I make this, the smaller the. I don't know. So I could have been using this for the last several hundred pages. Also, with the way that I'm making these videos, it's not last for you. What is happening here? This is definitely not the end of the road for you. This is the last page that I'm recording. Like I don't know, because of the way the pandemic went. I was on like page 215, I guess, or 213 when this started. So I went 213 to the end. Then for some reason I did 202 to 213. And then I went back to the beginning. So this is actually the last page I'll be doing. Anyway, this is 20. So this equation, in the event that we need it, is going to be x squared plus y squared equals 400. And I think we are probably going to need that. And also, I don't think I centered the axes correctly, but who cares? All right, target one goes at, let's switch color here. Target one, constant rate from here to here, and takes 20 seconds to do it. All right, so that's 0, -5, and 8, 14. I'm gonna write that, and then, so we're going from 0, -5 to 8, 14, 20 minutes. Okay, so what I'm gonna do is I'm gonna delete that, and then, I don't know, that's not what I wanted to do. I was gonna copy it. I'm gonna cut, and then paste it down here so that we can write let's just write that equation, right? Because that's a definitive thing that is definitely happening. So this is gonna be for target one. We know that x, y, so 0, -5, x is gonna add 8 in 20 minutes. 20 minutes? That can't be right. That's gotta be like seconds or minutes. There is a bird going nuts out there. What is happening? I really don't know. Something. And then plus 19 over 20. That can't be minutes. That's gotta be like seconds, maybe. 20 seconds. Yeah, I figured. So I don't. It's also like immaterial to the problem. Not really, but in terms of like doing the problem, that's not going to make a difference as long as everything is using the same units. Okay, so far so good. Well, maybe. Another target. Target 2, the second target, starts at 10.2 and ends at -6.7. All right, so the targets almost collide, but the first target passes through the point where they would have crashed, which is the intersection, 1 second before the second target. So we need to like think that through. And then maybe, I mean, this is different. So first target passes through the point where they would have crashed 1 second before the second. So if target 1 gets there at 5 seconds, that is 1 second before target 2, so target 2 gets there at 6 seconds. If target 1 gets there at 10, then target 2 gets there at 11. So that's like, you kind of have to work that out. So I'm gonna, so 10 to -6.7 at intersection 1 second after target 1. Okay, I'm gonna cut this and paste it down on our working page. This will be target 2. So it's important that you organize your work so that you can use it. Target 2. This, I probably should have put target 1 like up above. Target 1. All right, so I think we're like, we're on our way. Like, I think I know how to solve for, because we've done it several times, we definitely know how to solve for like how long target 2 takes. So like maybe we should do that right now. 0, -5. I don't really know like how to, 0, -5 and 8.14. 8.14 is inside this circle, like 8 squared plus 14 squared. Yeah, I guess it's like way less than 400 squared. So I'm gonna say this is like 0, -5, and then 8.14 would be like, maybe 8.14. So we got this going on, this target 1, and then target 2 is 0.2, 0.2, and then -6.7. Scale, and that's going to be hard. And also, I'm just like making this up. -6, 0 to -6.7. What do I have wrong here? 0. Oh, that's a 10.2. What? I thought that this was the parenthesis. It's not. 10.2. Okay, get out of there. 10.2. 10.2 is going to be like here, I guess. So I got to find a way to delete this without deleting. Got it. 10.2 and then -6.7. This seems more likely because it seems like they'll actually hit somehow. Here, I guess. 10.2. All right, so what I'm going to do is, for the rest of this video, I'm going to solve for how long target 2 takes, which like I think is probably a question. How long does it take the second target to travel from its starting to ending point? Yes. All right, so we know how to solve that. So part A, I'm going to say that this takes T2 seconds for a full trip. And we've solved this a couple of times at this point, or this kind of thing. So my equations, x2, y2, are going to be 10.2, and then we lose 16, but it takes T2 times T, and then you gain 5, T2 times T. Your time interval is 0, T to T2. All right, let's do part A. For part A, we need to solve the system x1 of T1 equals, so what does it equal? When are they both at the intersection point? So target 1 is there at T1. Target 2 is there 1 second after target 1. So that's going to be x2 of t1 plus 1, and then y1 of t1, y2 of t1 plus 1. And we will solve this for t1 and t2. t1 is the time target 1 is at the intersection, and t2 is total time for target 2. All right, I'm going to solve that on the calculator, obviously, because I'm not a crazy person. And then I'm going to like build it in Geogebra. I don't know if like this video is going to be long because of that, but like whatever, we got to do it at some point, and it's all just time, right? So let's change this to parametric. We'll add this in. So it's 0, I'm not going to type that, 8 over 20t, and then -5 plus 19 over 20t. And this should take until 20, but I'm changing it, but like for no reason. We don't really need that. And then, so this one is not going to work. Like we'll be able to type it in, but it's not going to work when we try to actually like do it. And it's going to ask us, do we want to make a slider? And we don't. T2, and then times t. And then what are you? 2 plus 5 over t2 times t. So do I want a slider? I do not want a slider, and therefore nothing will happen because it doesn't know what to do with t2. Let's add a calculator page and solve menu 3.7 system of equations t1, oh no, 2 variables, t1 and t2, or use x and y, however you want to do it, as long as you're keeping track. So I need to solve x1 of t1 equals x2 of t1 plus 1, because it gets there 1 second later. And then y1 of t1 equals y2 of t1 plus 1. Solve this for t1 and t2. Okay, so I'm going to jot those down. So t1 is 405 over 43. I mean, I feel like that's going to be relevant at some point. T2 is 1792 over 67. Yikes. All right, let's go back to the notes so I can like write a sentence, and then I'm going to go to Geogebra, make this part happen, and just see if we're right so far. And if we're right so far, we'll keep going. If we're wrong, I don't even know, burn it down. I'm gonna be so annoyed. So target 2 takes 1792 over 67 seconds for full trip. All right, let's build. So I'm switching to Geogebra, and you should, I mean, just do it on your own. You don't have to watch this, but if you're not sure how to do it, like you can watch. I'm gonna keep going. I'm gonna build the whole thing. So I'm gonna put in the circle and like whatever, which also may help us in the long run. So circle centered at the origin with a radius of 20, which I mean, I could have just put in x squared plus y squared equals. I don't know why I didn't. Zoom until we can see that. We're turning stuff off, right? So click, settings, labeling, no new objects. Can't stand it. Too many labels, just gets a little confusing. All right, and then let's do the curves. Curve 8 over 20t, comma, -5 plus 19 over 20t, comma t, and this goes from 0 to 20. Okay, let's put the starting point and the ending point. So a of 0, a of 20, and let's put a point on it. So a of v. So our slider is v, 0 to 20 so far. I'm not really sure. I probably need to go way higher than that to get like the full experience. Okay, so we have this point. I'm gonna change the color. So I'm clicking here, and then up here, I'm gonna click again and just make it this color. It's a little easier to keep track of. We could also name it. I mean, that's target 1. So maybe I should do that. Let's do the 3 dots for, click here, the 3 dots, settings. I'm gonna call this like T1. I don't know if it's case sensitive. It is. Okay, so T1, that's target 1. Close that. And now target 2, is there, I'm considering just storing 1792 over 67 as like its own thing and then like using it. But I think I'll just type it. Let's see, curve. It's like now I have to type it twice, and that's kind of annoying. 10 minus 16 over, all right, here we go. 1792 over 67 times t, comma, 2 plus 5 over parentheses. Let me scroll. 1792 over 67 times t, comma, t, 0 to 1792 over 67. Whew. All right, let's put the points on it. Note B. B of 0, B of 1792 over 67. No effort was made to make these numbers look good. And then B of V. So what is 1792 over, I don't know, is that bigger than or less than? That's like a slow target. Yeah. Okay, so that's not big enough. I need to go to, what do we think 1792 over 67 is? 20, 30, 40? Let's go to 40. I mean, it's definitely gonna make it to 40 because it's already more than halfway there. And then I gotta like, now we gotta fix things. Okay, so let's go. You know, I could just make it, let's do this. Let's make this what is it? 1792 over 67. Whatever. 26.75. Okay, let's fix T1. So that's this point. So you're going to be the minimum of V and you take 20. So it'll stop and so it'll look classier. There we go. Okay, and then let's also, while we're here, we got to do it right? So this point, I'm gonna click there, click up here, and change the color to this. And then also, I'm gonna hit the 3 dots, go to settings, caption, T2, because it's the second target. And so, I mean, a lot of this is just like taking pride in what you do. Like there's no reason to really have done that, but I think it's good to do that kind of thing. So let's see if we can do, we did store. So I know that A of 405 over 43 should put, oh wait, what am I doing? Oh, I know what I'm doing. Yeah, I want to change this to 405 over 43. This should put target 1 at the intersection. And it does. Okay, and then if I add 1 to that, and then I don't know how I change this back to a slider, but that's a problem for future me. So that puts point T1, which is this one, at 3.773.95. Now I'm going to change it to this +1, and it should put T2 there, and it does at 3.77 and 3.95. So that's working. How do I change this back? Let's go to, let's just make V equal 1. Okay, that's good. It's when you, yeah. I don't know, if you put in a weird thing, it changes it from a slider to like, I'm approximating something. So far, so good. This is where we're gonna end this video, I think. And I will be back in the next one to keep going. I mean, I think we've answered part of this. So let me quickly see what we did. We definitely answered A. And that is literally all that we've answered so far. So we're on the way, but you know, it's gonna take a while. So anyway, I'll see you in the next one where we're gonna try to answer B. So see you there.